So you want to know what systems are there in this SAD or what SADs are installed. You want to know what are the systems, right? Just you can go to the CD, USR, SAP. Under the SAP, you can see the list of SADs here. What systems are there? All the SADs, you can check it out here. All the SADs, you can check it out here. So in the other system also, maybe we have the two Linux boxes here. SAP, the Linux one also, we have the one system here. You have to log into the here. Okay, so here what you can do, you can also, sorry, go to the USR SAP, then it will give you the details. For any SAP details, if you go to the any SAP OS level, either Windows or Linux, if you go to the USR SAP, here you will see the list of SIDs here. List of SIDs here. In this SIDs, so it will tell you the what is the SID which you have installed, all the information it will tell you. So which means in this host, this SIDs are installed. In this host, this SIDs are installed here. This SIDs are installed, right? So this way. So let's check whether which one is up and running here, right? Which one is up and running? I think last time we connected UDB we connected here. The last time UDB on the SAP HANA host. SAP HANA host. I think UDB is not there. I think it's uninstalled. I think which one is installed? Anybody knows? Maybe passwords. Passwords are the very important here.
Sir, can you SDH, sir? Password is London 2023.
Which one? Which one?
SDH, sir. SDH.
PDH. Right? Oh,
sir.
yes, SDH. Okay. Yes, DH, SDH, SDH. Okay. So you need to switch it. You need to switch it SDH ADM with SAD, then HDB space info to check whether it is up and running. So it's not running. Why? Because you can see there is no process here. Process means our family members. There is no 7 family members here. Then in this case, HDB space start. Can use the HDB space pause start button. Then this will be started. This will be starting state. So one thing is HANA database will not start immediately. HANA databases will not start immediately here. HANA database will not start immediately. Just give me a minute. So see here now HANA database is getting started here. HANA database is getting started now. So HANA is getting started here. So which means backend, the 7 process will be up. Then the data, tables, everything will be loaded to the main memory, which means HANA main memory, it will be loaded here, right? So while it is getting started, so let's recap what we discussed till now, right? From last week onwards, what we are discussing. So the starting of the HANA classes, we discussed about the introduction about the HANA. What is HANA? HANA is a in-memory column-oriented columnar database, right? That one we know, everybody knows. It's a in-memory database. Means HANA, compared to the other databases, HANA will store the data in RAM level. RAM level means memory level. That is called the in-memory. In memory level, it will store the data. In memory level, it is storing the data, right? That concept we know. Apart from that, in memory level, it is storing the data here. So apart from that, we also know HANA, HANA is a, so it's a not only just storing the data, applications also can retrieve the data. HANA is a combination of hardware and software requirements. which means it's a combination of hardware and software requirements here. Okay, so let's see. Now I executed the HDB start. Now HANA is getting started. So let's see, once HANA started, then we'll see. Let's see here how much time it will take.
Hello, sir. Hello.
Yeah, now we can see HANA DB got started. So, right. So, see how much time it's taken to start the HANA database here. So, if you just open the HDB space info, HDB info, you can see now 7 core process got started. 7 core process got started here. 7 core process got started. So 7 core process got started here. Previously, when you use the HDB space info, so nothing is started. Now 7 are started, which means here, so 7 are started, which means HANA database is completely started now. So now you see free -g command to check the memory utilization. See here, 29 GB almost. So almost is used now, right? So why means you can see other databases also in the same system. So other databases also in the same system got started. Now see, previously nothing is there when I use this one. Now you see HPR ADM, HPR system, S4Z, SDH, which we started now. So total three are running here. See here, one host, three HANA servers are running here. Three HANA servers are running here, right? That's why you can see the memory, physical memory, almost 29 GB is occupied here. Only 3% is available here. Suppose if you want to stop the HANA DB, now you see free-g, which means 29 GB. It's in the data is there in the in memory level. Memory level. This is in the memory usage now, right? 29 GB. Now what I will do, I will log into the suppose example. So S4G, okay, S4G ADM. I will switch to the S4G ADM, right? Using the sudo command. Using the sudo command, I will switch it. Then just I will execute the HDB space stop. HDB space stop. Stop means stopping. If I stop it, what will happen? Data will be reloaded. Data will be deleted. Data will be flushed out from the memory. Then this 29 GB, the used space will be reduced now. So you see now, you will see now. Why? Because when you HANA is on, all the data will be stored into the memory level only. Memory level only. If the HANA is stopping, then data will get flushed out from the main memory. For starting or stopping the databases will take the some time. Why? Because data will get loaded. So that is the concept. We will come that delta merge and save point. That concept will come that time. So we may have to do that one here. So we can see HDB stop here. HDB stop here. So here you can see, so all the services are getting stopped now, which means whatever the data is there in the main memory, once it is stopped, you will come to know how the memory got reduced here. Now used is the 29 GB. Once the HANA stopped, it will be reduced. Okay, that will happen now. So once done, you guys need to add to the here, right? Suppose like now you can see previously we added the SDH SAP HANA, right? So now let's just go to the systems, add the systems, then SAP HANA. SAP HANA is the host name here. So then instance number is the SDH, instance number is the 01. I can say 01 is the instance number. So 01. So 01, it's a single container. Then system database you are adding. Then system is the user, database user. Then London 2024 is the our password, right? So just I am using that password here, our common password, but it's not
23, sir. Not 24. 23.
Yes, it is added now. You can see it is added now. Same time, I am going to add to the tenant also here. Tenant, right? So how to add the system? That is what we discussed last time here, right? So SAP HANA. Yes, Aditya, tell me.
Sir, if any of the services won't start, like, so we can get to know, right? Like, which
Yeah,
services.
Yeah,
not
right. We will come to know. We will come to know in the display. In the display, we will come to know which one is not started, which one is started. All the information we will come to know.
okay. Okay, sir.
And also we can also check the log why it is not starting and all the information. So now you see,
Okay.
so it is stopped status. So HANA database is stopped status here. So which means now you see free-G means to check the RAM memory usage now here. So you can see here in the differences here 29 GB it is used, right? When you stop the one HANA database here, you can see 15 GB. 15 GB means total 12 GB. No, 12, yeah, 12. No, 14 GB, I think. Yeah, 14 GB. So 14 GB got freed up here. 14 GB got freed up now. Free means, so whatever the database you stopped here, right? The database got some occupied the some data, some memory in the RAM level. When you stop the database, what will happen? Data will be flushed out from main memory to disk level. Disk level, it will be flushed out. So that's the reason. So HANA is a one of the in-memory database. In-memory, so column-oriented columnar database. So that is what we discussed in the introduction class. Also, we discussed about the difference between the HANA 1.0, 2.0 here. HANA 1 means it's a single container standalone database here. One single, there is no system DB, 1080 DB concept. So HANA 2.0 is the multi-container database. HANA 2.0 is the multi-container database, which means by default, it's kind of apartment concept. Independent means only one family can stay. Apartment means more families, more floors we can put it. Each floor, one ground floor system DB, first floor tenant DB, then first floor one more tenant DB. Like that, we can add the multiple tenants up to 19 tenant databases. We can create it manually. We can create it here, right? Which means one system database by default, which one will come as a tenant database plus 19 database, total 20 tenant databases, one system DB we will get by default. In one host we can create it here, right? So that is the HANA 2.0. This is what we discussed. After that, HANA editions we discussed. HANA is available in the 3 editions. HANA Enterprise Edition, Platform Edition, Extended. This is not much important, but we discussed it. But Platform Edition is the one of the edition. Each edition we have the database softwares. Additional softwares also available, depends upon the license. The license they are segregated into 3 types actually here. One is the Platform Edition, Enterprise Edition, Extended Enterprise Edition here. 3 editions. So depends. Everybody will use the Platform Edition only. Why? Because this is standard. All those things you will get. If you need some additional functionalities, then extended edition we can take it out. If you need more, then enterprise edition, extended enterprise edition. So like that, enterprise edition, extended enterprise edition. Like that, you have the 3 editions that is in the HANA database here. Any edition, you have the common HANA DB software plus HANA client plus HANA Studio plus HANA cockpit. So plus add-ons or plugins. These things will be available in the each and every edition. So we have to download in the service marketplace. Then we have to install on the Linux OS, right? Either Red Hat Linux or SUSE Linux. We need to install the HANA databases here. So here you will come to know these are the 7 cores. Or when you install the HANA database, either 1.0 or 2.0, you will get the 7 core HANA process. You will get HANA process. You will get here 7 core HANA process. You will get in that. One is the index server. The second one is the name server. The third one is the preprocessor. The fourth one is the compile server, right? The fifth one is the web dispatcher. The sixth one is the access engine. The seventh one is the access engine. The seventh one is called the daemon. These are the 7 HANA core process will be created when you're doing the HANA installation 1.0 or 2.0 here. So 1.0, 2.0 both will get, but 2.0 is the multi-container. Sir, you told that one system DB, one tenant DB is coming, right? But wherever this process sit here. So here every tenant database, you have the every tenant database, you have the index server, then access engine will be in the every tenant database. So the remaining process are there, those will be in the system database and preprocessor in the system database and compile server in the this database, then access daemon is in the this database here, system DB. So both are in the this databases here, name server, preprocessor, compile server, then web dispatcher, this all 5 are in the system DB, remaining 2 are in the this one. This what we discussed. Then HANA installation can be done using the HDB LCM tools, right? So these tools was introduced to HANA 1.0 SPS 10 onwards. So everybody has to do the HANA installation using the HDB LCM tools, HDB LCM tools here, HANA 1.0 SPS 10 onwards, we have to do it here. HANA 1.0 SPS 10 onwards, we have to do the using the HDB LCM tools. Okay, then we have started installing the HANA database, then HANA 2.0, right? That's why we have the one system DB, one tenant DB got created, right? Up to here we are clear, right? Up to what? Up to here we discussed the high level. Then we have discussed about the overview tab. In the overview tab, we got the all the process, then system usage, when is the last restart happened, what is the version of the HANA database, what is the build time, when which OS you have installed it, what is the OS version, what is the OS kernel version, what is the memory usage currently. So you can track it here. So total 32 GB RAM memory, 35 GB RAM memory here. So what is the percentage currently it is occupied? What is the percentage currently it is occupied here? Percentage it is occupied here, right? So this one we got it here. Percentage we got it here. So here while adding the system DB, tenant DB, system DB always you will get the initial thing is the system DB at the rate of SID. Tenant DB at always it's a SID at the rate of SID. Simple. So this is the way we can differentiate it. One more thing is, so while system DB, right? Okay, system DB contains the 5 process only, 5 process only. So where you have the name server, preprocessor, compile server, all the 5 process are there. That is called the system DB. Where you have the index server is available, that is called the tenant DB. Tenant DB index server and access engine is available. That is called the it is called the tenant database, right? Every tenant database you have the one index server, one access engine, the process are available. So then every system DB we have the remaining 5 process are available here. That is what. So we in this way we can identify which process this one like this here. So OS level, where can we find the HANA systems logs? I will come to that part here. Still, I have not explained about the file system logs. I will come to that parts. Okay. So overview tabs. So here, go to the landscape tab here. In the overview landscape tab here, we can find the in the landscape tab here we can check the list of HANA process. How many are there? We can process it here. So here you can see. So we have the compile server, daemon, index server, name process are there. Here we can see the process status here, our process related port number here, in which host this process are running, whether it's active or not. In case of it is not active, it will come to the red status. Suppose like example, I'm trying to, let me try to kill the one process here. Okay, let me try to kill the one process here. If I go to the landscape tab, so what I can do, so suppose if you see it here, right click and so just we can cancel it. We can also stop the process here, kill it. We just if we can also kill the process here. If we kill it, what will happen? Here you can see in the system DB we have only 5 process here, right? Which means this is the system DB. Wherever you have the system DB, but simply in the display itself it will give the information system DB, right? So same, but in the tenant also we have the 7 process are double, not the double actually here. Here those process are coming from the system DB only, but in the tenant also it is showing. So it's a system DB process. Like here, see here, web dispatcher is getting started automatically. It will start it here, right? So see here, ICP utilizations and memory utilizations, right? So here, if you see, so April 21st, 9:58 last restart start time, 33218. If I go to the here 33218, if I go and refresh it here, you see, so web dispatcher is getting started here. Web dispatcher is getting started here. Then the port number, which means the process, so 332, the process which is coming here, the process which is coming here is showing as a, which is the index server system DB process here, the process which so here the name server web dispatcher, you can see it here. So same process, system DB process, just in the display it will show, but it's not like that. It's not like that. Tenant DB also having the same set of process. It's not like that. Just only tenant DB, the additional process are index server, access engine. Only these two are it's not, but remaining all are derived from. In the display screen, it is showing as a set of process, but it's not like that. Tenant DB process. This process are from the system DB process here. This process are from the system DB process here. Okay, so that is the, so one thing here we can say here, right? In the alerts tab here, in the alerts tab, yeah, it's true. Answer to your question, yes. So why? Because so why it will start, it means, so I need to explain this 7 process related information now here, right? So HANA process related information now. First process is the index server. What the index server will do here, right? So index server is available in the tenant DB. Also, the index server responsibility is to store the data. Index server responsibility is to store the data in the database level. So whenever any data is coming from applications, it will store into the index server. Index server is the main process in the family. So in the family, how the father is the main process. Here also the index server is the main process in the all this process. Index server is the main process in the here, right? Also we can load the data, we can unload the data, all the calculations, everything will happen in the index server itself, right? So tenant database, all the data will store in the tenant database, in that only index server only. Index server is responsible to store the data, all the calculations, loads, all the engines, query engines, all the engines are available. It will help to store the data in the database level. That is responsible process is the index server. So that is why index server is the master in the tenant database. Master of the database. Who is the master? Then tenant. Master of the home means how we can say father. Same as like the master of the HANA database is called the, so HANA database process is called the index server. Index server is the master of the HANA database process here, right? So that is the index server here. Okay. So your index server is available in the tenant database only. So all the applications will connect to the index server only. Why? Because tenant database. Index server means tenant database. Why? Because in the database level, where the data is storing, index server. Index server is available in the 1080 dB. So all the SAP application, client applications, everything will store in the database level. Everything will store into the database level here, right? So index server only here. The next one is called the name server, name server. So index server, name server. So name server holds the topology related information. Index server will hold the topology related information. Topology related information means the host name, right? SID, instance number, so IP, all the details, it will hold it. It will keep it. It will hold it here. If any process is then this will help to index server. This will help to index server here, right? So that is the responsibility of the index server. Each process has dedicated responsibility. In our home, we have the family members, right? Father, mother, child, kids, right? So same as like here in the database server also. So we have the database server. Database means so one newly constructed house database. Inside of the database, who will there? Family members, same family members, right? So then here HANA process inside of the database, HANA process. So in the family, our family members, how we will perform our roles and responsibilities, same as like here also, we will perform our roles and responsibilities here. Father. So father means he is the main in the database, means index server is the main in the database. So he will perform all the loads, calculations, burdens, storing the data, all those things will be done by the index server. So same as like our father, right? The name server. Name server is some kind of one child. So he will just hold the house related information, like your system related details, he will keep it here and will help to the index server as and when required, right? That is the responsibility of the name server, index server, name server. And the preprocessor. Preprocessor is processing the unstructured data. Processing the unstructured process. Preprocessor is responsible for processing the unstructured data. So in the database level, one of the advantages is not only structured data, database can process the unstructured data also. Database can process the unstructured data. Database can process the unstructured data also here. Database can process the unstructured data, right? Means suppose structured data means will be in the coding programs, C++ programs at the rate of like structured program means normally when you're writing the programs, do while, then something open bracket, then close bracket, something like the programs we will write the C++ programs, right? That is the structured data. Sometimes different data will come. So database has the capability to process the unstructured data also. The data is not in the structure, so that will process unstructured data also will process by the preprocessor. Preprocessor will process the unstructured data, right? So that's why HANA database has the more advantage in that this is the unstructured data. Then it will process the unstructured data, will help to index server to store the data. Then compile server, compilation of the programs, stored procedures, programs and stored procedures here, procedures. So what this will do, compilation of the programs and stored procedure, compile server, compilation of the programs and stored procedures here, compilation of the programs and stored procedures here, which means in the database level also, database means database also there is a coding, right? So what is the programs, right? What is the programs are written here to build the database? C and C++ programs. So suppose if any new program or anything, so here compile server will help to that program. Compile server will will execute the compile. Compile means speed up here, speed up here. To speed up the programs or stored procedures, here compiles will take it out, then will help to index server, will help to the index server here, right? Then web dispatcher, web dispatcher. So web dispatcher is a responsibility to handle to take the take the web dispatcher will take the request from the web. Web means browser. So normally we as a administrator we are using the HANA Studio, one of the Eclipse based tool we are using, and we are using, and we are doing the our work here, right? So but sometimes what happens, the developers or application team members, some other users mobile application to develop it, they will use the browser based URL. Browser URL they will use, they will through via browser also they will connect to the HANA database, they will load the data, right? Browser means in the mobile also it is available, everywhere it is available. You no need to install anything, just browser is the tool, you can use it. So studio means we need to install the studio, that is for the administration purpose. So here web dispatcher, if any request which is coming from the web browser, it will take the request, will assign to the access engine. Access engine process the browser based request, and will help to index server to store the data in the database level, will help to the index server, will process the data here. Then daemon, so daemon process here, right? Daemon process here. Daemon is like a daemon process is like, so daemon is the very important here. So here index server, access engine, both are in the tenant database. Remaining 5 process are in the system DB, right? So each one will coordinate it here. Suppose if we ask compile server to do the index server work, means it won't do. So why? Because every process has dedicated coding is written here. They will write the dedicated code is written. They will write the they will write the, they have written the code so that based upon the code and instruction, the particular process will perform only that activity only, right? Suppose if you click the brake, if the accelerator is on, then that is the different procedure, right? So every program has specific set of instruction only. Okay, that program will do only that related actions only here. So daemon process is responsible for out of daemon. So index server is the father, right? We will act as a call. Why? Because it's the main process here. So here the remaining process are the child, sons, so maybe daughter, something like that. If you think like this, then daemon is like a mummy. So which means daemon, if any process in a family, normally family means 5 or 6, 7 members, 8 members, that is depends. But here in our family, database family, we have the 7 members here. In that 7 members, if one family is, if any one of the family member, right, either father, child, sons, any one of the family members are sick. Sick means is sick or faulty in the database level, we will call it as the faulty. Any faulty means any process is error stopped, anything, the daemon will go, will give the boost to that process, will bring up to the online status. So if I talk about the database language, if any HANA process are in red means stopped status or faulty, the correct word is the faulty, then daemon daemon process will bring back to online, right? Someone asked a question now, which is the process will bring back to online here. Suppose example, I am just stopping the web dispatcher, one of the process I am stopping here now, right? So what if I stop the daemon process here? What if I process in, so now I'm going to stop it now. I'm going to stop the one process now here, right? In the system DB, right click, and then let me stop it here. I'm stopping here, right? You see, it will come to the red status now. Red status. So now immediately, oh, one of my family member is having the red, means sick or faulty status. Immediately, so now you see, just wait for 1 minute max. Just click on the refresh. Automatically, that process will come to the green status here. See here, the starting mode. So yellow means starting the process here. Just you can just click on the refresh button. So this starting mode. So which means, so if any process is dead, means stopped. So ma'am, family members may definitely somewhere, some cases regularly during the day-to-day run, long run, we may have some sickness. So something like that. So in that case, if any process is in the sick, so immediately the daemon will go and bring back to the green status here. See, it's in the green status now. Right? That is what it will do here. The daemon process stopped, entire DB is stopped. Entire none of the process will be alive. Again, you need to completely down. We need to check the issue and we need to fix it. We need to start it here. Right? That is what we have to do here. So daemon is down means, so it's even then we need to everybody we need to go, we need to bring back all the process. We need to stop it. We need to bring back here. Right? So then that is the process related, each and every process related information here. So each and every process will perform the individual responsibilities here, right? So the next one, alerts tab also we discussed, right? Alerts tab, and if alerts means, suppose we stopped the web dispatcher. See here. So it's saying that someone restarted the web dispatcher, was restarted this time. So 2 times restarted, 9:59, 10:40. 2 times we restarted. Like this, we are giving some errors here. Means alerts. Any process dead or something, immediately you will get the alerts, high priority alerts. So whatever the email ID you have done the configuration here, you will get the emails. You will get the emails here, right? That is the one. So the next one is the performance tab here. The new tab is performance tab here. In the performance tab, in the HANA database, if any issues, in the HANA database, if any performance issues, in the HANA database, if any performance issues means slowness, anything, first thing is we have to come to the here, we need to see session. Whenever you connect to the HANA database, there is a one session will be initiated, one session, one HANA database, one user related session will be opened. Suppose you see this session is running here, which means here who is running what? So who is the user? I am the user here. I opened the HANA Studio application. Then what is the version? With me, I am the administrator. I logged administrator. I'm not only one person, one more person also is connected. And with the database user is the system user, what it is doing, what is the IP, what statement is executing current statement, then how much data he pulled it out. So how much, what is the average duration, all the information you have here, right? In this way, we can find out whenever user logins, the session will be recorded here. Each session, once the user login is not only doing simple work, then multiple actions he will perform. He will connect to the one database, but he will perform the multiple actions. The multiple actions are related to the here. So multiple actions means what is doing. Each action, there is a thread, one thread. For one session, multiple threads will be initiated, right? So each session, multiple thread. One session means one user is logged in. Then after that, once user log in, he will go to the multiple tabs, multiple buttons, right? How I am going to the this tab, this tab, this tab, this tab. Same way, one session, multiple threads, right? Each action, one thread is occupied here that will process the related activities and everything here. So blocked transaction means if any transactions are blocked database level, it will show the blocked transactions here. Blocked means, so DB deadlocks, any deadlocks or something is happened, it will show the information. SQL plan caching. So SQL, all the SQL statements, database level, whatever you are doing, whatever the activities are running, how the database storing the data means each and everything will use the, so one is SQL statements. Each and everything will use the SQL state. Who will convert it? So here here the converting by, so in the index server only, index server has inbuilt process to convert the data here. Index server has some inbuilt process to convert the data here, right? So you can see list of SQL process here, who executed, what time they executed, all the information will be stored into the data here, right? You can see the information. This is the SQL plan cache, which means all the SQL statements will be stored here. So that using this statement, it will pull the data, right? Who is the user, who is the user, who is the user. Then SQL trace, in case of trace on, to find out why, because database level, whatever will execute, that is as a one SQL statement only. Sir, we have not written any SQL statement, right? You no need to write it. Database internally will use this SQL statement. Whatever the logic you are doing, you are going to this button, and you are right click and stopping and starting means backend it will issue the one SQL statement. That statement will do the related activities and everything will be performed here. That is what we have to do, right? That is the performance tab. So one thing you need to, need any issues in the DB level, you need to come to the performance tab. You need to see how many sessions are there, how many threads are there. All those things will show the display here. How many sessions are opened, how many threads are active. Here, all the information will be opened here. Okay. So that is what we need to check here. Okay. So so this is what here. So let me check 1 minute. Yeah. So here you can see uh, the process. If any DB related issues, all the first tab which comes into the mind, performance tab. Here you have to come. So you can see what is happening in the database level, who is the user, how much data is retrieving, what is the duration from is active. So how much data is fetched, from which duration, user, you administrator user. So what it is running, all the information you will get the details from the sessions and threads tab here. This is the one of the important thing, right?
Hi, sir.
Yes.
Can we kill the user session, sir, here?
Yeah. Some of the sessions we can kill it, some of the sessions we cannot kill it here. Right click, and suppose you see this is the very, so this is the some of the sessions. Suppose this is no user. Some of the user sessions is trying to pull it. We can cancel. We can cancel the with operations here. See here for this session is depend on the this threads here. All you want to cancel all the threads, just cancel it. See here canceling the operations here. Right. So like that, we can cancel it. The user actively is pulling the fetching the data, lot of data is fetching. So which means definitely there is a performance issue, database level, right? So yeah, there is no limitation. N number of users can log in concurrently. You can do the activities and everything here. There is no limitations of the sessions wise and everything. They can log in, they can do the transaction. Only thing is system should have the proper memory, proper space, proper CPUs. Then it will survey the all the requests. It will help the all the users request and everything here, right? So that is what we can say it here. So only thing is should have the free memory. Why? Because everything will happen in the RAM level, RAM level. So if you keep on waiting, you see here. So previously we have the 15 GB used, now 17 GB used, right? Then if you use the free -G again, then you can see 18 GB, which means so in a minute, so the lot of memory it is pulling the it is grabbing, means HANA database is using the memory, means it is using the memory. So that's what when I keep on, if you keep on using it is doing. So should have the enough memory. That is what we have to require here, right? So CPUs, memory, that's why voice level commands we discussed initially. Okay, everybody connected. Let's start practicing the up to performance tab and see what is happening here. So all those things you can see it here, right? See here, lot of sessions are initiated now, right? So what they are doing, so all the information will be tracked here. So in this way, we can find out, so suppose system is very slowness, then you can just log into the here, you can see, so who are the users are logged in, then what exactly they are doing here. So what is the, how many number of queries they have initiated? Oh, this person is logged in. What is the number of records they have fetched, right? What is the query time here, right? So query time. So then average time here. So all the information they have recorded, all the information they are recording here, right? So that is what we need to check here. Okay. So that's the for today's class.